Welcome to the fourth screencast for the FOSS Air and Weather Unit of Study. In this screencast, we will look at Investigation 3, Wind Explorations. This investigation has 5 parts and is designed to be completed in 4 sessions over the course of 2 weeks. The student learning outcomes for this investigation are: observe and compare the action of moving air and its effects on pinwheels, bubbles, and kites. Write a description about how the air moved the object. Observe and describe the direction of the wind using wind vanes. Write observations in a notebook. Observe and describe the speed of the wind using an anemometer. Record data in a notebook. Describe, explain observations and inferences made from the investigations, both orally and in writing. For example, wind is moving air. Wind speed and wind direction can be described using anemometers and wind vanes. Wind scales are tools used to describe the speed of the wind. The Student Learning Outcome document can be found on the Boston Public Schools Science Department website. Check out the Air and Weather Overview screencast for more information about the BPS Science Weebly and resources available for teaching this unit of study. In Part 1, Bubbles in the Wind, students blow bubbles outside and observe how air moves bubbles in different locations around the school building. You will need a breezy day for this activity and an area around your school building that includes walls, corners, a wind-protected area like a courtyard, and some open space. This is so that students can observe how wind moves bubbles around these obstacles. In Part 2, Wind Speed, students go outside to feel the air and observe wind speed. They use 2 new tools to measure wind speed: the wind scale sheet and an anemometer. Be sure to watch the FOSS Web teacher preparation video to see how to set up a class anemometer. In Investigation 2, students began using the cloud type sheet to identify kinds of clouds. Each sheet was placed in a sheet protector. I like to add the wind scale sheet to the back of each cloud type sheet and place it in the same sheet protector. This way, both pages are protected and available for easy reference during science in the schoolyard. Also, students will be recording their wind observations in their air and weather journals. Consider using pieces of cardboard with binder clips as inexpensive clipboards so that it is easier for students to record outdoors in any weather. In Part 3, Pinwheels, students make a new kind of pinwheel and compare it to the class anemometer. Pinwheel construction can be tricky, so be sure to watch the FOSS Web teacher preparation video so that you know which straws to use and how to cut them to make a pinwheel. After testing their pinwheels indoors using a fan or hair dryer, bring students outside to test their pinwheels on a windy day. Like the anemometer, the pinwheel is a tool for measuring air speed. In Part 4, Wind vanes, students construct their own wind vanes and compare wind vane movement to the movement of bubbles and clouds. Like the pinwheels, the wind vane requires some fussy cutting of poster board and more than one kind of straw. Again, be sure to watch that FOSS Web teacher preparation video for details about how to make and use the wind vane. Like bubbles, the wind vane is a tool that helps us identify wind direction. Students take their wind vanes outdoors and use them to determine whether clouds are moving with the wind or against the wind. After Part 4, there is a FOSS Science story about meteorology, understanding the weather. Reading and writing are an important part of scientific literacy. To develop these skills, the BPS Science Department created close reading resources with text-dependent questions for each unit in grades K through 12. You can find the complex text selection, Understanding the Weather, and teacher-developed text-dependent questions on the BPS Science Weebly under the Science and Literacy tab. In Part 5, Kites, students construct kites. Then they use the anemometer and wind vane to determine the best location and direction for kite flying in the schoolyard. Watch the FOSS-Web teacher preparation video to see how to construct Kite 1 and Kite 2, and then choose the kite that you would like to construct with your students. After testing kites indoors, fly the kites outdoors. Remember to bring the anemometer and wind vane as tools to use to determine the best locations and direction for kite flying. In this investigation, your students learned that wind is moving air and that meteorologists use tools like wind scales, anemometers, and wind vanes to measure the strength, speed, and direction of the wind. Happy teaching!